Hi, in this video, we're going to take a look at private versus public IPv4 addresses. So, as we've talked about in previous videos, that because of the limited number, 32 bits, 4.29 billion addresses of IPv4, we're running out of IPv4 addresses. We have for a long time. This actually started in the or recognized in the early 1990s. And so there had to be some short-term and long-term solutions to this problem. Short-term solutions included things like network address translation, private address space, and classless interdomain routing. The long-term solution is IPv6, and it is definitely happening now. All right, but the focus of this video is to focus really on private addresses. That, along with NAT, has really kept IPv4 around, probably a little longer than it should have. And we'll talk more about that in later videos. Private IPv4 address space. Okay, this is defined in RFC 1918. Matter of fact, it's sometimes called 1918 address space. So that's an RFC number you should be familiar with. And it defines certain ranges of addresses. Matter of fact, these might look familiar to you. Your home network is going to have an address somewhere in this range here. It uses one of these network addresses. Most businesses, most colleges, universities, schools, hospitals, businesses, just about everybody uses these private addresses. It has what has saved IPv4. Okay? Even IANA reserved another special group of addresses, as we see there, the 100.64/10 address space that providers can use. And I'll mention that more in a moment. It's similar to RFC 19 address space, but it's used primarily by service providers. Okay, but here's the key thing here. And let me show you what I'm talking about here. The private address space, these addresses here that are used in private networks, by businesses or whatever. Okay, the problem is that routers will not forward, or should not forward if they're configured properly, any packet with a destination or source IPv4 address that belongs to these networks. The key thing with these private IPv4 addresses, and let me just clear this here and use an example here. There we go. For example, the 192.168.1.0 network, that can be used by anybody's network. Anybody can have that network. Matter of fact, a lot of your home routers use that address for allocating IPv4 addresses to the clients. The thing is that this address, if you want to communicate outside this network, then your address, which would be a source IP address going out, would have to be translated to a public address routed by the internet. And the internet will have to send a public, or some server out there in the internet like Amazon or Google is going to return packets to that public address, and it will have to be converted back to your private address as a destination IP address. By the way, that's known as network address translation. All right, so let's continue talking a little bit about this stuff. Okay, so public IPv4 addresses are those reachable via the internet, routed by service providers. Private IPv4 addresses are not reachable via the internet. Okay, packets with a source or destination private IPv4 address are not propagated or not forwarded by internet routers. They typically will either drop, or if you're using NAT, translate these addresses. Talk about NAT in another video. Okay. All right, so let's take a look here. So this NAT has been used to kind of hide customers. So what do we mean by that? Let me kind of go show you what I mean. So somebody with in the internet, either the public internet or another private network cannot reach this address directly. Okay, that's because it's not reachable. Anything with a destination IPv4 address going to any private address is going to be dropped by internet routers. Okay, this is not security. Okay, so the IETF continues to state that NAT was never meant as a security feature. It kind of hides your devices, but it's not security. I mean, it's kind of, if it was security, then we'd have no security problems in our internal networks, right? So we know it's not security. Anyway, I won't go into that in this video, but NAT does create problems. Okay, it creates problems for peer-to-peer networking, latency, breaks several applications. So it was meant as a short-term solution. All right. There's also something I want to make you aware of called carrier grade NAT. Because we are running out of IPv4 addresses, including the providers are becoming, in many cases, severely limited. Instead of translating your home network address, your RFC 1918 address, which is commonly then NATed to a public address, well, a lot of ISPs are running out of public addresses. So they convert it to another private address. Remember that RFC 6598 private address space for providers? And then, so they use that within their own network, and then finally they will NAT it to a public address as it leaves their provider space. So it actually gets translated twice, and this can cause all kinds of problems, port forwarding and other things, and latency. So this is known as carrier grade NAT, sometimes known as NAT44, because you're translating it twice, and can break all kinds of things like console gaming, video streaming, peer-to-peer applications, and geolocation, just to name a few. This is why we need to go to IPv6. Besides, we're just plainly running out of IPv4 addresses. We have no choice. Okay, there are some other special IPv4 addresses I just want to mention. There's the loopback address, which is used to direct traffic to your own device, from your device to your device. Okay, a lot of times it's used for testing purposes. Okay. There's also in IPv4 a link local address, which is different than the link local address we talk about in IPv6. But that's an address that Windows uses, 169 address, also known as a automatic private IP addressing. But Windows uses this address if the device is trying to get an address automatically from a DHCP server. We'll talk about that in a later video. And the DHCP server is either not there, or can't reach it, can't talk to it. But in any event, it can't get its address automatically, so it gives this address to itself. So whenever you see that 169 address, especially on a Windows device, notice that probably something went wrong and that device did not get a proper IPv4 address. All right, so I hope this helps you understand a little bit about private and public IPv4 addresses.